Hi, today I want to look a little bit at this break-even analysis. The idea of break-even analysis in a location decision is to gather up cost information from each of your potential locations and just look and see, well, where would it be the least expensive to produce at differing quantities. So this is a example I'm pulling from a textbook, and I have these three locations in Ohio and two in Pennsylvania. But the fixed costs vary. Now, why would the fixed costs vary? Well, remember, fixed costs came from fixed inputs. So apparently the cost of capital and the use of capital in each of these places is a little bit different. And the variable cost per units, they are more tied to, for example, your labor costs or any type of resource that can vary in the short run. So I have a variation. I mean, if I were reading this, it's almost like, oh, we used more labor in Sandusky because the labor costs are higher, and less capital because the fixed costs are lower. And then down in Pittsburgh, I would say the exact opposite. Okay, well, we use less labor because the variable cost is lower, but I use more capital because the fixed costs are higher. So the information in this table leads us over to these three equations, showing me a variable cost for each of these curves. So let me get the labeling right while we're sitting here. So I have a total cost function for each of these curves. Now, what I would like to do, because that's just the process, is create a picture of each of these expressions. So to create a picture, what I need to do for Excel is I need to give it some values for the domain. So I need a column with output in it. And then I need a column where I've got the total cost from each location as a column heading. All right, I'm going to just, this is obviously not necessary. I'm just going to make this look a little bit better. Okay, well, how do I set up my domain? Now, I've kind of cheating because I've went and I've looked at this problem earlier. I'm going to set up my domain as I'm going to choose Q starting at 0 in 250 unit increments. This is what's going to work for me. And I'm going to run this out until I get to 5,000. Okay, 5,000. Actually, let's go to 6,000. Maybe that'll make this picture look a little bit better. Okay. So what I have done is I have specified the numbers that I'm going to have appear on my horizontal axis, my domain of interest. All right, well, I'm now going to construct the total cost function for Sandusky, Ohio. There's a fixed cost of $30,000 per unit plus a variable cost of $40 per unit times the amount of the variable input that we use. Excuse me, times the amount of output. Apologize for that slip there. Okay, well, there's my first calculation, which should be 30,000 when I get it straightened out. Why is it 30,000? Because I'm producing no output, so all I have are fixed costs. That's why I knew what I was looking for. Okay, well, let's set up the same thing for Erie, Pennsylvania. I have a fixed cost of 55,000, a variable cost per unit of 30 times the number of units. And again, I expect when I push return that this will come out to 55,000. And finally, for Pittsburgh, Pennsylvania, I have a fixed cost of 100,000 plus a variable cost of $20 per unit times the number of units. So 100,000 is what I would have expected when I have zero output. All right, well, let me just copy this down and make some room so we can see the numbers. What am I looking for? Well, let me put it in a picture and then come in to the table and show you what we're looking for. All right, so I'm going to create a picture just like we have in the textbook. I'm going to have just as line charts. Well, actually, this is a scatter plot, but I'm connecting the points with lines. Okay. All right, so what does this tell me? All right, this blue line is this column H, so blue line. The red, well, orange, whatever color that is column I. The gray line is column J. So when I set out to do this process, what I'm looking for are the places given an output size, which of these three locations have the lowest cost? Well, between an output level of 0 and this intersection, the first location, Sandusky, Ohio, has the lowest possible cost. And then from here until this intersection, Erie, Pennsylvania has the lowest cost. And for output levels beyond this point, Pittsburgh has the lowest cost. All right, well, what I need to find are these intersections. Now, I don't need to find this one because that one's not relevant. Right? What do I mean by not relevant? It's never providing me with a minimum cost. At the output level where these two intersect, Erie, Pennsylvania provides the lowest cost. So I don't have to worry about this one. But I do have to worry about these two. So what can I do? Because of my well-chosen table, what I can do is I can look for an output level where total cost 1 and total cost 2 have the same value. So, kind of scanning down here, looking for total cost 1. Oh, there it is. Total cost 1 and total cost 2 having the same value. So let me mark it so that I don't lose it. So apparently, for 2,500 units, or excuse me, 0 to 2,500 units, Sandusky, Ohio is going to be the low-cost location. But from 2,500 units on, it's going to be Erie, Pennsylvania, until this intersection. So now I'm looking for an intersection, moving down the table, where Erie, Pennsylvania and Pittsburgh, Pennsylvania have equal costs. So don't need to start at the top. I can start right here at this line, and I am looking for a location, there it is, where these two have the same cost. Okay, if I get my fingers to work right for me, we'll get that marked as well. Okay, so I can start answering questions now. And the first big question I might want to answer is, what if I am producing less than 2,500 units of output? Well, for output less than 2,500, build in Ohio. For output between 2,500 and 4,500, I want to be in Erie, Pennsylvania. For output greater than 4,500, Pittsburgh is my choice. So that is how I would summarize this location decision. Okay. All right, now, anything else can I say? How did I know? How did I know how to set up my output level? How did I know that I could force it so I could see what I wanted in my table? Well, what I did is I went in and I said, okay, where is total cost 1 equal to total cost 2? So I actually took these two equations, I set them equal to each other, these two, and solved for Q. That's what gave me my 2,500. That's how I knew what I needed to set up. And then I looked at this other intersection over here between total cost curve 2 and 3, and I did the same thing. I said, where is total cost 2 equal to total cost 3? Set them equal to each other, find the output level where they're equal. That's how I found the second one. So I knew before the problem started that I needed an output level of 2,500 and 4,500 in the domain. So I purposely set up my domain at these 250 unit increments so that I would have these two numbers in my table. So there in a nutshell is how I construct these break-even charts. Once again, I am looking for the minimum cost. So I'm just following as I move from left to right the curves that give me the minimum possible cost. And that is the curve of interest. Thank you.